Hello, welcome to our next lesson. Previously, we have talked about all the different angle pairs with parallel lines and a transversal. And today we're going to look at things from a different perspective and see what happens when we don't have parallel lines, but we like to prove that we have parallel lines. So before we jump into the actual lesson, let's go ahead and review real quick. Previously, we said if two parallel lines are cut by a transversal, then the following four things are true. Corresponding angles are congruent, alternate interior angles are congruent, alternate exterior angles are congruent, and consecutive interior angles are supplementary. Again, every single one of these is dependent on this initial fact that if two parallel lines are cut by a transversal. So because these lines are parallel, all four of these things are true. So what we're going to look at today is what happens if we don't know that lines are parallel. How can we prove that two lines are parallel? So first, we're going to take the converse of each one of these, so we're going to switch the hypothesis and conclusion, and we're going to say if corresponding angles are congruent, then lines P and Q are parallel. So for example, in this particular example, if angle 1 and angle 5, the measures are equal, meaning the angles are congruent, then P is parallel to Q. Now this symbol right here, the two lines like that, that's a symbol for parallel. It's how we show that one line is parallel to another line. And each one of our angle pairs is going to have a converse. So the next one's going to be if alternate interior angles are congruent, then lines P and Q are parallel. So in this example down here, if angle 3 and angle 6 have the same measure, meaning they're congruent, then line P will be parallel to line Q. If alternate exterior angles are congruent, then lines P and Q will be parallel. So in this particular example, if we have the measure of angle 1 equal to the measure of angle 8, meaning the angles 1 and 8 are congruent, being alternate exterior angles, then line P and Q will be parallel. And then finally, if consecutive interior angles are supplementary, then lines P and Q will be parallel as well. So again, if the measure of angle 3 plus the measure of angle 5 is equal to 180 degrees, then P and Q will be parallel. So example 1, we want to determine if lines are parallel. The instructions tell me to find the value of x that makes m parallel to n. So again, it's important to point out that lines m and n are not parallel lines. They're not given to us as parallel. They don't have the mark on there showing that they're parallel. And what we're being asked is that what value of x will make these two lines parallel. So in order for these two lines to be in parallel, the corresponding angles need to be congruent. So the two angles that I have, 71 degrees for the upper right-hand angle, and then 2x plus 3 for the second one, we want to know how can I get 2x plus 3 to equal 71? So that's how we're going to set this up. We're going to say 2x plus 3 equals 71. What value of x is going to give me 71 for the measure of the second angle? So we'll just go ahead and solve, subtract 3 from both sides. I'm going to get 2x equal to 68. Divide by 2 on both sides. And x is going to equal 34. So again, what we're saying here, this is kind of a big, long if-then statements, a kind of series of if-then statements, is if x is equal to 34, then 2x plus 3 is going to equal 71. Well, if 2x plus 3 equals 71, then we can go ahead and say that these corresponding angles are congruent, which brings us to our corresponding angles converse, which says if corresponding angles are congruent, then m and n are parallel, which is what we want. So basically, we can kind of take the beginning of this, the first if that we have, if x equals 34, and we can tie this together with my final then statement, which is then m and n are parallel. So if x is equal to 34, then m and n would be parallel in this case. In our second example, we're going to use the transitive property and show how it relates to parallel lines. So we have 6 utility poles that are all in a row. And each pole is parallel to the one next to it. So what that means is that line T1 is parallel to line T2. T2 is parallel to T3. T3 is parallel to T4. T4 is parallel to T5. And then T5 is parallel to T6. Now the transitive property happens when I have two different things. Sometimes it's two numbers that are equal to the same number. I can say they're equal to each other. In this case, I'm going to use that with parallel lines. And I've got T1 parallel to T2, and I've got T3 over here also parallel to T2. So since T1 and T3 are both parallel to the same line, T2, I can go ahead and say that T1 and T3 are parallel to each other. And then I can go ahead and take this a step further. So T1 is parallel to T3. Well, T4 is also parallel to T3. And again, since both of these lines are parallel to the same line, I can say that T1 and T4 are parallel to each other. So you can see where this is going. So T1 is parallel to T4. Well, if T1 is parallel to T4, well, T4 is also parallel to T5. So we can go ahead and say that T1 is parallel to T5. And then lastly, we can go ahead and make the connection right here and say that T1 is parallel to T5, T6 is parallel to T5, therefore T1 is parallel to T6, which is what I was trying to show the entire time, that the leftmost pole T1 is parallel to the rightmost pole T6. And again, this is by using the transitive property of parallel lines. That's it for this lesson. Go ahead and try the You Try Nows. Again, make sure you guys, if you have any questions, you're writing them on the side. And remember that for You Try Now number 3, that two lines are parallel if they have the exact same slope. The slope formula is given for you. So double check slopes and make sure two lines are parallel by ensuring they have the exact same slope. Again, write down questions and ask them tomorrow if you have them.